So Chapter 3, Lesson 6 is Estimate Quotients. It says here, for a craft activity at a daycare, each child will need 1.75 yards of ribbon and 2.8 yards of fabric. Okay, so each child will need 1.7 yards of ribbon and 2.8 yards of fabric. There are 25 yards of ribbon and 30 yards of fabric available. We want to estimate the number of children that can participate in the activity and explain our reasoning. So here, let's see. We want to know how many kids are going to be able to get some ribbon, right? So we want to take the 25 yards of ribbon and we're going to divide that by 1.75, but we're going to estimate, right? So let's see. We can say that 25, and does everybody understand that this fraction bar means divide? Okay, so this says 25 divided by 1.75, right? Okay, so here if I divide 25 divided by, let's say 2, right? That's going to be about, well, that's going to be 12 and a half, so it's going to be about 12 kids, right? So about 12 kids. All right? Now, so this is for the ribbon, right? Let's write ribbon here just so we know what we're talking about. That's for the ribbon. Now we need to find out how many kids can get some fabric, right? So we've got 30 yards of fabric, and each kid will need 2.8 yards of fabric. So we're going to round here. So 30 divided by 3, very good, we'll round that to 3. That means that we're going to be able to give 10 kids some fabric, right? So if 12 kids will be able to get ribbon and 10 kids will be able to get fabric, how many kids are going to be able to participate in this activity? 10. Very good. Because then we're going to have some extra ribbon left over. Does that make sense? So the final answer here is 10 kids will be able to participate. All right, so for example 1, we are going to estimate 11.75 divided by 3. So here we're going to round the dividend, okay? We're going to round the dividend. So 11.75, that will round to 12. And then now 12 and 3 are compatible to divide mentally. So 12 divided by 3 is 4. For example 2, it says the Jenkins family bought 5 tickets to a charity auction. The receipt shows the total cost of the tickets. We want to estimate the cost of each ticket and justify our answer. So here the total cost is $61.25. They purchased 5 tickets. So here, if I want to round the $61.25, that will round to about $60. So now 60 and 5 are compatible. 60 divided by 5 is equal to 12. All right, so for the first example we have, and you guys don't forget, I want you to write your original problems so that you know what you're working with, okay? So we're estimating each quotient. Problem A is 49.3 divided by 7. So here the dividend, 49.3, is what we are rounding. So 49.3 rounds to about 49, right? So we have 49 divided by 7, which is equal to 7. Now, I want to talk to you real quickly about the rule that we learned yesterday. Remember yesterday we said we were going to round to the greatest place value, right? That was the rule that we learned yesterday. So here, if I use that rule, rounding to the greatest place value, this would be 50. But does everybody see that 50 and 7 are not compatible to divide? Does that make sense? So here we had to move away from the actual rule that we learned yesterday. Does that make sense? All right. So let's look at example B. So example B says 98.1 divided by 25. Now, here, if we were going to round, we would say 98, right? If we were going to use our rule from yesterday, that would work out fine, because if we're rounding to the greatest place value, 98 would round to 100. Very good. So 100 and 25 are compatible to divide. So 100 divided by 25 is equal to 4. All right. So suppose the Jenkins family decided to purchase 6 tickets for a total of $64.50 using a discount. We want to estimate the cost of each ticket, and then we want to justify our answer. Okay? So, in this problem, we are going to divide the $64.50. I'm going to just write it, $64.50, and we're going to divide by 6 tickets. So bear with me. All right. Now, if I were going to round to the nearest whole number, then this would be about $65, right? So I'm going to write $65 here. Is 65 and 6 compatible to divide mentally? No. Now, if I rounded to the greatest place value, that would be, no, well, this would be 60, right? This would be $60. Are 60 and 6 compatible to divide? Yes, they are. So we would think that we could do that, right? But that's a low estimate. So bear with me. Because that is a low estimate, because we still have that $4.50 to contend with, we wouldn't be able to use the 60, okay? So when we take out the 65, we said that's not a good one, and then we take out the 60 because that one would be a very low estimate, right? So here, let's see if I just said 66, okay? So let's use 66, and now if I divide that by 6, we will get $11 a ticket, about $11 a ticket, right? Now I just want to use a calculator to check it, okay? Per ticket. Okay, so let's take our calculator. And here, if we actually do $64.50 and we divide by 6, that's $10.75, which is about $11 per ticket. Is everybody clear? All right, so now we're going to estimate by rounding divisors. So you can also estimate quotients of decimals by rounding the divisors. Now remember, the dividend is the one that's being divided. The divisor is the one it's being divided by, right? So we can choose compatible numbers that are easy to divide mentally. When we're talking about compatibility, okay? Now everybody look at this. Look at this right here. It says, how does the division fact 63 divided by 9 equals 7 help you estimate the quotient of 63 divided by 8.4? Okay? Now, if we're looking at 63 divided by 8.4, if I'm using the rules and rounding, 63, this would be 63 divided by 8, right? But are 63 and 8 compatible to divide? No. So here we have to go away from the rule and bump it up 1 to 9. So 63 divided by 9 is equal to about 7. Does that make sense? Okay, so here is where it gets a little a little subjective, okay? So, for example 3, we are going to estimate 32 divided by 3.9. Of course, 3.9, we can round that divisor to 4, and 32 divided by 4 is equal to 8, okay? So, let's take a look at example 4. Here we're going to estimate 56 divided by 6.8, okay? So here we want to round the divisor. Which one is the divisor? 6.8, and we're going to round that to a whole number. The dividend is 56. Very good. So we want to round 6.8 to a whole number that is a factor of 56. Okay? So 6.8, we can round that to 7. 7. Okay? So now when we divide, we have 56 divided by 7 is equal to 8. So 56 divided by 6.8 is about 8. All right, so here we want to estimate 54 divided by 9.16. Okay, make sure you write down your original problem. Make sure you write down your original problem. So when we round, we're going to round the divisor to a factor of 54. Okay, so 54 divided by 9.6, we can round that to 9. 9. So 54 divided by 9 is equal to 6. Got it? All right, how about with example E? For example E, we want to round the divisor, that's the divisor, to a factor of 99. Okay, so we want to round the divisor to a factor of 99. If I look at 10.75, according to the rules, according to the rules, 10.75 can round to 11. Very good. So we're going to have 99 divided by 11, which is equal to 9. A Pacific leatherback turtle can have a mass of up to 704.4 kilograms. An olive Ridley turtle can have a mass of up to 49.9 kilograms. About how many times heavier is the Pacific leatherback turtle? Okay, so here we're comparing. I'm going to write this down so that you know what to divide. Okay, we are dividing the Pacific leatherback turtle, right? So Pacific leatherback turtle, and we are comparing that to the olive Ridley turtle. Does everybody see that? So that's how this one is just like that other example we had yesterday. So when we're doing this division, we're going to divide the 704.4 divided by the 49.9. So when we round, and the squiggly equal sign, that means it's approximately equal to. That's what happens when you round. It becomes approximate. We can round the 704 to 700. Very good. And we can round the 49.9 to 50. And then when we do that division, we get 14. Is everybody clear? All right, so that's supposed to be an olive Ridley turtle, right? So O-R-T.